the icy waters of the Arctic, north of Barrow, Alaska. A major change in conditions from the mouth of the Columbia River, where swift drifters spent the summer of 2013 measuring waves, winds, and currents. Swift was developed by APL-UW's Jim Thompson. In September of 2013, graduate student Seth Zippel took Swift to the Arctic.
We're walking on the ocean.
The first time the Swift's in the Arctic, it went great.
This was the first test of Swift 3.0, the Arctic version of the Swift.
Kind of beefed up for the Arctic. We've made the hull all aluminum instead of plastic.
Seth put the drifter in a patch of open water in strong wind conditions.
It was also cold enough that the ice would start freezing. So normally when it's cold, the ice, if there's no waves and it's a calm surface, it'll freeze like a lake. In this energetic condition with all these waves, it almost looks like a slush, or some people call it grease ice. It was really like a slush the Swift was sitting in. What I was really excited for, drifted in and you could see the wave response really well. There are these high frequency waves with all this texture, and then there's almost a line drawn right in the water, and you could see the waves were really smooth that were propagating into that grease ice. So the little bits of ice and slush that are in that patch of water are actually stopping the high frequency waves from getting through, and then the waves that are getting through are modulated a little bit.
Excited by the science, Seth always kept the price tag in mind.
It's probably like 60 grand for each Swift. My biggest concern is getting it back.
The Swift emerged encrusted in ice, but in good working order.
It was only in for 2 hours, and it was totally frozen over on top, a couple inches of ice, and it was sea ice, so that's salt water. It's like colder than freshwater ice. I was really excited to see it, to be honest. I thought it was cool looking.
Cool looking and communicating findings despite the cold and the very northerly location.
All of the instruments data is sent to the central brain. This processor is running some of our processing code, and then it emails it back to us here at APL. And that's something we weren't sure would work at high latitudes, how well the satellite connections would be up at 76 degrees north. And that worked great. So we were receiving emails the whole time the Swift was out there taking data.
The plan now is to take more Swift drifters back to the Arctic in 2014, to the marginal ice zone where the ocean meets the edge of the ice pack. The prime objective, a better understanding of ocean surface waves in the presence of sea ice. In particular, how melting ice might lead to a larger ocean, which in turn creates bigger waves and increased navigation dangers.
Understanding that response will help with wave predictions in the Arctic. So as the ice melts, there's a lot more boats navigating through the Beaufort, the Chuchki, going through the Northwest Passage. It's certainly a dangerous environment too, especially near the ice. And if you can make better predictions based on your knowledge of the physics between the wave, the ocean, and the ice interaction, you can definitely improve safety in those regions.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.